Okay, so we're out in the garden here today, children, learning about how to add vectors together. And in case you forgot, you can go and watch that Despicable Me video about what a vector is. It's a quantity that's got size and direction, because some things in life don't just have size. Mass only has size, so many kilograms, but weight's got direction as well. Weight is downwards. So mass is a scalar quantity, while weight is a vector quantity. And this year, you're going to need to know how to add vectors together. The rule for adding vectors is that we always add them together nose to tail. And you can see over there in that wee diagram on the far side, I've pointed out for you which end is the nose and which end is the tail. And if you forget, it's much like adding together elephants. You always add them together, nose to tail. I don't know if you've tried adding elephants together before, but if you haven't, that's how you should do it. So, as an example, we've got a 5 and we've got a 12. Most maths teachers will tell you that 5 and 12 get 17. Let's check out and see if they're right. Add them nose to tail. Pause the video, join those vectors together nose to tail, and see how long it is. So it turns out in this case that the maths teachers had it right. 5 joined on to 12, nose to tail. Doesn't matter if you did it the other way around. 12 plus 5 is 5 plus 12. Addition's like that, subtraction's different. You've got to do it the right way around with subtraction. But 5 plus 12 really is 17. And you'll notice that we put a double head on that resultant vector just to show that it is the sum of those other two vectors. Now let's have a try and see if we can work out what do we get if we add 5 and 12 together and don't get 17. Now that reminds me, one key thing I forgot to say on that previous little example we did was that the resultant vector went from the tail of the first one to the nose of the last one. That's how we knew where to draw that resultant vector. I want you to once again join those two vectors, the 5 and the 12, together, nose to tail, and then work out the size and direction of the resultant. Now it's best for your learning if you pause this video now. Don't just watch me do it. Okay, so hopefully you did it something like that. Key things are that we had to add together the 5 and the 12 nose to tail. Once again, it didn't matter whether you did the 12 first or the 5 first. Addition's like that. And the resultant, we drew it from the tail of the first one down to the nose of the last one. And that would have been the same if we'd done a 12 plus a 5. Doesn't matter. To work out the magnitude of it, the length of it, we just hit it with a bit of Pythagoras, the square root of one side squared plus other side squared. I especially chose those numbers so it came out nice, exactly 13, but you check you can get that on your calculator. Then the second part, we had to do an angle, and when you're trying to find the direction of a vector, having an angle relative to one of the other vectors is about where we're at. If it's looking down, you might have worked out a compass bearing from north, but to get that, you would have had to work out one of these angles anyway. So, I chose that one and drew it on as theta, so it was really clear what my direction angle was, and I calculated up that angle was anti-tan of 5 over 12, but bear with me, I'm not very good at doing anti-tans in my head. I have to go and find a calculator. And it's lucky I went to get that calculator because it gave me a chance to notice that the 12 is the opposite side and the 5 is the adjacent side, and so in fact there's no point anti-tanning that, but rather that's the one that we should be anti-tanning. Now, if you're struggling to see why it's tan, we can work on doing some trigonometry revision together, but that's not the purpose. of this video. 67.4 degrees.